All right, so we are doing 12.4 here. What we're doing is we're starting with volumes of figures. So what we've done so far is find surface area, which is basically, we've talked about how surface area is just finding the area of all the faces of an object. Now what we're going to talk about is volume, and what volume means is if we were going to fill an object up, how much space is actually on the inside. So again, we can look at these formulas, and this is the main formula that we're going to use, because when we're dealing with prisms, here is what we want to remember. It says volume equals capital B times H. What does that mean? It means capital B will be the area of the base. So if you notice, if you look at this right here, if I can find the area of that base right there, okay, so that's the bottom of my little box, same thing over here. If I have my bottom of my box over here, if I take the area of that entire base, then literally the only thing we have to do is multiply by how high it goes. So from here, if I know what a flat part of this is, and I multiply by how high it goes, that will give me what the volume is. Same thing here. The area of the base times how high it goes will give me the volume. Same thing with the cylinder. It's the same formula. It's area of the base times how tall the cylinder is. You know, think of it as like a stack of paper. So if this bottom sheet of paper was there, and we could figure out the area of that paper, if we find the area of that sheet of paper, and then we multiply by the number of sheets of paper in that stack, we could find the volume of that stack of paper. So area of the base times the height for both of these. You can use these formulas if you want to, but again, it's just more for you to remember. If you can just remember the idea of area of the base, whatever the base is, find the area of it, times the height, that will always give you the volume. So let's look at some examples. So this first one is, of course, one of our more difficult ones because the area of the base is not always as easy. But here's what I always start with. I say volume equals capital B times H. And then from there, I just try and figure out what my B is. So B is my base. So area of my base is going to be 1/2 times little a times capital P. Apothem, perimeter. Our perimeter here is going to be 12.8 because that's one of our sides, times 6. Okay, and when we do that, we get 76.8. So our P is 76.8. Okay, so plugging this in, we get 1/2 times our apothem is 11.1, times our perimeter is 76.8, and we get a value of 426.24. So that's the area of our base. Now, what we've said is all we need left is the height. The height is the height of our object, the distance between bases. Okay, very important for us to understand the difference between the height of a base and the height of our actual object. And I'll talk about that in our next example. So again, the height is the distance between the bottom base and the top base, which is 11. So we're just going to do volume equals 426.24, that's our B, times our height, which is 11, and we get 4,688.64. And now our units change. Now it's going to be cubic units because we're finding the volume of something. The volume is three-dimensional, so that's why it's got a power of 3. So it's cubic units. Okay? All right, next one. Let's run through this. Again, same formula. Volume equals capital B times H. B is going to be the area of the base. Again, you know what your base is because they're parallel to each other. They're exactly the same. There's 2 of them. And because it's a triangle, the area of the base is going to be 1/2 times little b times little h. Now, here's where it's very important. This can be confusing to a lot of you. This h right here is representative of distance between bases. Whereas this h right here is just the height of the base. So they are different h's. Okay, so we look at 1/2 times base times height. So the base of our triangle is 10. The height of our triangle is 8. So that gives us 40. So our area of our base is 40. Okay? So now that we have 40 for our base, now we can use our actual volume formula. Volume is base, which is 40, we already figured that out, times the height. Now again, don't make the mistake of thinking that the height is 8. The height of when you're finding volume is the distance between bases. So that's where the 17 comes in. That's the distance between bases. That's the one mistake that many of you may make there. And when we multiply those two, we get 680 inches to the third power. Okay? So let's move on to another one. So let's assume that this is a cylinder. Okay? Same idea though. Volume equals capital B times H. Again, now we assume, okay, the base is a circle, so that means we get pi r squared. Plug these values in. So pi times, and our radius is 4.61. Again, all we're doing is using formulas and plugging stuff in. First, identify what your base is. What type of shape is it? It's a circle, so it's pi r squared. We plug this in and we get B is equal to approximately 66.73. So that's our B. Our height is going to be our 30. So volume equals 66.73 times our height, which is 30. And we get a total of 2001.95 centimeters cubed. Okay? So that's that one. The last one is a little bit more difficult, but again, let's focus on the first part, and if you don't understand the second part, we can talk more about it in class as we go to it. So again, we have base times height. It's circular pool, so that means it's going to be cylindrical. So our B, our capital B, is pi r squared, which is equal to pi times r. So our diameter is 18, so therefore our radius is 9. And when plugging that in, we get 254.34. So that's our area of our base. Now we just simply multiply that by the height. So we have volume equals 254.34 is our capital B, times the height is 3 feet, because that's how deep it goes. And that is equal to 763.02 feet cubed. Now, let's read the problem. It says, how many gallons does it hold? Feet cubed is not gallons, but we're given what our conversion factor is here. And this becomes a little bit difficult. So watch how I do this. I start with 763.02. That's feet cubed. We need to eliminate this. We need to get it to inches cubed and then to gallons. So what we do is we figure out how many inches, how many cubic inches are in a foot. And it's not 12. It's got to be 12 to the third power. So that means there is 1,728 cubic inches in 1 foot. Now what happens is the feet to the third and the feet to the third cancel out. Now we convert inches cubed to gallons. So it'll be 1 gallon on top over 231 inches cubed. And again, now our inches cancel out, so all we're left with is gallons. So we multiply across the top and divide at the end. So 763.02 times 1728 divided by 231 is 5,707.79 gallons. And again, I get that that part was hard. That's a more difficult problem. But again, if you got to this point right here, if you understand that, then you do understand the concept of volumes and plugging things into our formulas. So again, that's really all I have. Don't forget to take your Edmodo quiz if that has been assigned to you, and bring questions with you to class. So I'll see you then.